Section 9.1, Translations. The mapping of a geometric figure that results in a change in position, shape, or size of a figure is referred to as a transformation. The original figure is referred to as the pre-image. So this is the image before, or this is the shape before it's been transformed. The resulting figure, or figures, after the transformation is referred to as the image. So the image is the shape after the transformation has taken place. A transformation that preserves distance and angle measure, in this case, we say size and shape, is called a rigid motion. So here we see examples of rigid motions. Flipping the shape over does not change its size or shape. Sliding it does not change its size or shape. Or turning it does not change its size or shape. Which transformations appear to be rigid motions? Well, in this case, in A, this is a rigid motion. All they've done is flip the picture over. They're the same size and shape, they've just been flipped. In B, this is not a rigid motion. The size is different. And then in C, this is definitely a rigid motion. Because all they've done is slide the shape over and then flip it over. So it's a combination of multiple movements or transformations, but in this case it's still the same shape and same size. What are the images of angles F and H? So remember, the image designates after transformation. And so in this naming here, they tell us that EFG, in this case this means transforms into E prime, F prime, G prime, H prime. So the images of angles F and H are angles F prime and angles H prime. They use the prime, or the, I guess in this case you could say, little mark at the top here to indicate the image. So F was the pre-image, F prime is the image, so it's after the transformation. They slid the point up there. H, same thing, they slid it up, it became H prime. What are the corresponding pairs of sides? So here we know that in this case, since they're assuming this is a rigid motion, FE should be congruent to F prime E prime. We also know that EH is congruent to E prime H prime. And we also know that GH congruent to G prime H prime. And that FG is congruent to F prime G prime. Here they practice the same idea, but we're pretty good at this, so we're going to go ahead and skip this. We should know that the angles, in this case A and B, would go to A prime, B prime, and you're just matching up the matching pieces. So here we're talking about translations. A translation is a transformation that maps all points of a figure in the same direction, or the same distance in the same direction. So it's a slide, you're moving it in a particular direction at a particular distance. And so every point of the shape gets moved the same distance and in the same direction. So we write transformations using a capital T, and a transformation is a rigid motion with those properties. So it's going to move things in the same direction and the same distance. When we're going to write a translation rule, you'll see the capital T and you'll see brackets like this. And let's say they want to move it 3 to the right, they'd put a 3. Positive 3 tells you this is your X movements. And then let's say they want to move it 2 down, so that'd be negative 2. So it's telling you move 3 to the right for your horizontal movement and down 2 for your vertical movement. All right, and this will make more sense as we go. So the diagram at the right illustrates a translation of 4 units right and 2 units down. This is shown with the function notation t bracket 4 negative 2. This notation is used for translating the shape ABCD to its image A prime, B prime, C prime, D prime. So this indicates your horizontal movement, where the other one indicates your vertical. So this is important. Keep this in mind because you're not only going to have to apply translation rules, but you also have to write your own. Here they want to know what are the vertices of PQR given a translation of -2, -5. Graph the image of PQR. So here we have PQR, and it's in our best instance to note the coordinates. So for me, I know that point P is currently seated at 2, 1. Q is currently at 3, 3. And R is currently at -1, 3. So I'm going to go ahead and put those on my graph here. So 2, 1, 3, 3, -1, 3. So there's triangle PQR. Now we want to translate this by the translation rule given, -2, -5. And so ultimately all we're doing is we're going to add those into the points we started with. So in this case, P prime, we have -2 plus 2, which gives us 0. -5 plus 1 gives us -4. So P prime is at 0, -4. So 0, -4 puts us here. We could have also just counted backwards. So we're going 2 left, down 5. Well, that puts us right there. So this would be P prime. For Q prime, same idea. We'll take 3 plus -2, which gives us 1, -5, or 3 plus -5 gives us -2. So in this case, we're looking at 1, -2. So this is Q prime. And then R, same idea. -2, -1. Well, that's going to give us -3. 3 plus -5 is -2. So we've got -3, -2. And so R prime is here. And so this is our image. Number 2, what are the vertices of ABC, or the image of ABC, after a translation of 1, -4? So let's go ahead and identify the starting vertices of our triangle ABC. So A is at -2, 2. B is at 1, 1. And C is at 0, -1. We'll go ahead and plot those real quick. So -2, 2 is here, 1, 1 is here, and 0, -1 is here. So we want to translate this based on the translation rule. It says 1, -4. So for A prime, we take -2 plus 1 gives us -1. 2 plus -4 gives us -2. So A prime is at -1, -2. Do the same thing for B. So B prime is going to be at 2, -3. And then C, same idea. You've got C prime is going to be at 1, negative 5. And if we wanted to, we could have just counted. So we could have gone down 1, 2, 3, 4, and then write 1. And that would have taken us to B prime. So there's multiple ways to do these problems. All right, example 3. This time they want us to graph the coordinates for x, y, and z, and then do the translation of 1, negative 2. So x is negative 4, 3. Y is 2, 4. And z is negative 1, negative 4. So there's our triangle. And so now we want to conduct the translation of 1, negative 2. So go ahead and move this triangle by the translation rule of 1, negative 2. And then when you're done doing that, unpause the video and check your answers. So go ahead and do your work, pause the video, and then unpause it when you're ready to see your answer. So if you've done your translation correctly, your x prime coordinate is negative 3, 1, y prime is 3, 2, and z prime is 0, negative 6. Question 4, same idea. Let's start by graphing our triangle in this case. So negative 1, negative 3. So we've got our triangle XYZ here. So they've asked us to translate by negative 4, 2. So that means we're going to move negative 4, or we're going to move 4 to the left and up 2. So go ahead and conduct this translation and see how your shape changes. Pause the video, and when you're ready to check your answers, unpause it. So if you've done your translation correctly, you get x prime to be negative 5, negative 1, y prime is negative 3, 4, and z prime is negative 2, negative 1. Here they're asking us to write a rule that describes a translation. So what is the rule that describes the translation that maps PQRS to PQRS, or PQRS prime? So all we need to do is take one of the points from one of the shapes. So let's say we start with P, and we're going to figure out how we go from P to P prime. So let's start with the horizontal movements. So I'm going to move 1, 2, 3, 4, 5, 6, 7, 8. I'm moving 8 to the right, and I'll move 1, 2, 2 down, so we'll make that negative 2. Okay, so I moved 8 right, 2 down, and so 2 down is going to be like a negative 2. So that means my translation rule for this would be T bracket positive 8, negative 2. And so that's my translation rule. I moved 8 units to the right and 2 units down for every point on PQRS. The translation image of LMN is L prime, M prime, N prime, with L prime being 1, negative 2, M prime being 3, negative 4, and N prime being 6, negative 2. What is the rule that describes this translation? So this time they didn't give us both graphs, instead they gave us the image coordinates and the graph of the pre-image. So let's just focus on L and L prime. So I know that the coordinates for L, looking at the graph, are negative 6, negative 1, negative 1. And I also know that L prime is 1, negative 2. So the question is, how do I go from one to the other? So to go from negative 6 to 1, they had to add 7. Then to go from negative 1 to -2, they had to subtract 1. So that means they went 7 right and 1 down. So that means for this particular movement, our translation rule would be 7, -1. And that's your translation rule. So a composition of transformations is a combination of 2 or more transformations. You perform each transformation on the image of the previous transformation.